The story begins in silence. Imagine a vast, dark space where an hourglass floats, suspended in nothingness. Its frame is carved from obsidian, its glass delicate and gleaming as though spun from frozen light. Sand trickles downward in a perfect stream, each grain a symbol of a second slipping into history. For a moment, everything seems ordered, precise, unchanging. But then, with no warning, the glass fractures. A fine crack spreads across its surface, and from that single fault line, countless new fissures emerge. The sand does not fall in one direction anymore. It scatters into infinite streams, branching like rivers through a shattered landscape of time. This is the image with which our journey begins. The fractured hourglass, a metaphor for alternate time pathways. Humanity has always assumed that time flows like the steady descent of sand in an unbroken glass. Past leading to present, present leading to future, one straight and irreversible direction. Yet, as the fracture suggests, what if this belief is merely an illusion? What if each grain, each second, can fracture into countless possibilities, creating endless versions of history? The idea is both exhilarating and terrifying. It implies that destiny is not carved in stone, but fragmented, unstable, perhaps even chaotic. The opening of this story is not meant to offer comfort, but to stir unease. For when we speak of time, we are not speaking of something abstract and distant. Time defines us. It is the silent architect of memory, the invisible current that carries us from birth to death. To fracture time is to fracture the self, to imagine lives unlived, choices unmade, versions of reality where everything familiar is lost. And yet, as haunting as this sounds, the human spirit is drawn to the mystery. We are compelled to ask, if time can fracture, what lies beyond the cracks? The prologue sets this stage with a deliberate contrast: order versus chaos, certainty versus mystery. We open with the image of the perfect hourglass, timeless and reassuring, only to see it broken. This is not simply a visual, it is an emotional strike. The comfort of predictability is replaced by the vertigo of infinite pathways. Just as the shattering glass refracts light into many beams, so too does the shattering of time refract history into many possibilities. This duality will follow us throughout the journey. Hope against fear, freedom against uncertainty, wonder against dread. Consider how fragile our understanding of time truly is. We wear it on our wrists in the form of watches, track it with calendars, and live by schedules that give the illusion of control. But deep down, no one can explain why time moves forward, why we cannot return to yesterday, why tomorrow is always out of reach. The fracture in the hourglass forces us to face these uncomfortable questions. What if time does not move forward at all? What if it only appears to flow, while in reality, every possible moment exists simultaneously, like pages of a book waiting to be read? This imagery of a fractured hourglass is not new. It echoes through myths, stories, and scientific theories alike. Ancient civilizations carved symbols of cycles and eternal returns into stone, as if suspecting that time is not linear but layered. Philosophers wrestled with the paradox of the present moment, so fleeting it cannot be grasped, yet so essential that without it, neither past nor future exists. And now, modern physics suggests realities far stranger than myth, where time bends, splits, and dances at the quantum level. The hourglass becomes more than a metaphor. It becomes a lens through which to examine the deepest mysteries of existence. The opening must also plant seeds of curiosity that will echo through every chapter. Imagine a single choice, a coin flipped, a word spoken, a path taken or ignored. In one universe, the coin lands heads, in another, tails. In one universe, the word is said, in another, it is swallowed in silence. In one universe, the path is followed, in another, abandoned. The fractured hourglass suggests that all of these possibilities are real, splintered into different flows of sand, each one continuing endlessly into its own future. But if this is true, who are we? Are we just one version of ourselves among countless others? And if so, what becomes of meaning, responsibility, or destiny? Cinematically, the prologue imagines this moment as a sweeping montage. First, the steady tick of a clock, then the slow fall of sand, then the sudden crack as everything shatters. We cut to stars streaking across the sky, rivers splitting into deltas, mirrors reflecting mirrors into infinity. Each image whispers the same truth. Time may not be what we think it is. Just as glass can fracture, so too can the very reality we call home. This beginning is not about answers. It is about opening the wound of mystery. The audience is left with a haunting vision, a sense that the ground beneath their feet is less solid than they believed. Time, the most familiar of companions, is suddenly made alien. The prologue does not comfort, it unsettles. It does not conclude, it lingers. It leaves the audience suspended in the air, the broken hourglass still spilling its sands, as though daring them to follow where the fragments may lead. And so, with one image, the fractured hourglass, the journey begins. It is a journey across myths, across science, across the strange corridors of philosophy and the unsettling chambers of human imagination. It is a journey into a world where time is not a single pathway, but a shattered labyrinth. And as we step forward into this labyrinth, we are faced with the most dangerous and beautiful question of all. Not what time is, but what it could be. Before equations and laboratories, before physics tried to measure time with precision, humanity turned to myth to make sense of the unseen current that governs all existence. Across the ancient world, time was not a mere sequence of numbers ticking on a dial. It was a force, a deity, a cycle, and sometimes a terror. Civilizations, separated by oceans and centuries, all built stories around the same elusive truth. Time is more than we can see, and it may not move in a single, straight line. Imagine standing in Mesopotamia, the cradle of civilization, watching priests trace patterns in the stars above. For them, time was inscribed in the heavens, written in the movements of planets and constellations. The Babylonians believed in vast cycles where history repeated, a cosmic rhythm mirrored in their calendars and rituals. In their vision, time was not fractured but circular, endlessly looping, where every event was destined to return. The idea carried both comfort and fear. Comfort because it suggested continuity, that nothing truly ends. Fear because it suggested futility, that no choice could ever break free from the cycle. Travel east to India, where Hindu philosophy imagined time on a scale so vast it dwarfs human imagination. There, time was measured in kalpas, cosmic ages stretching for billions of years, where universes are born, flourish, decay, and are destroyed, only to begin again. This eternal recurrence paints a universe that is never still, always in motion, where destruction itself is simply the prelude to creation. The figure of Shiva, the cosmic dancer, embodies this truth, every step a rhythm of time, every movement a fracture that leads not to chaos, but to renewal. Unlike the fragile linearity of modern clocks, this vision gave time an infinite resilience. Now, turn west to the Greeks. For them, time had two faces, Chronos and Kairos. Chronos was linear, measurable, the steady march of seconds and hours. It is Chronos we still cling to today with calendars and deadlines. But Kairos was something different. Time is a moment of opportunity, the perfect instant where fate could shift. In myths, Kairos was depicted as a fleeting god, bald at the back of his head, so that once he passed, he could never be grasped again. This duality reflects a profound understanding. Time is both relentless and alive, both mechanical and deeply human. It is not only the ticking of the clock, but the charged moment where lives change forever. The Mayans, watching the skies from their pyramids, constructed one of the most intricate calendars in history. For them, time was not an endless road but a wheel, turning through cycles of creation and destruction. Each cycle carried its own character, shaping destiny itself. Their prophecies spoke of worlds ending not once but many times, only to rise again. When we look at their calendar today, often through the lens of apocalyptic fears, we miss the deeper truth. The Mayans saw time as a living organism, something that breathes, dies, and is reborn. The end was never an end, only a transition. The Egyptians envisioned time through Ma'at, the principle of balance and order, contrasted with Isfet, the force of chaos. Time for them was not neutral, it was a battlefield. Each day, the sun god Ra journeyed across the sky, only to descend into the underworld at night, where he fought the serpent Apophis before rising again at dawn. This eternal struggle symbolized more than sunrise. It revealed time as fragile, dependent on constant victory over chaos. To the Egyptians, time was not guaranteed. Each sunrise was an act of survival, a reminder that existence itself hangs by a thread. Even in Norse mythology, time carried a shadow of inevitability. The myths speak of Ragnarok, the twilight of the gods, where everything, gods, men, and worlds, would burn, only to be reborn from the ashes. Here, time is not endless repetition, but a cycle punctuated by endings so cataclysmic they shake the imagination. To the Norse, the future was known but unavoidable, a paradox of predestination that echoes our own fear of fate versus free will. What unites these myths is not their differences, but their shared refusal to see time as a flat, lifeless line. For the ancients, time was alive, cyclical, divine, unstable, full of mystery. Where modern science seeks precision, they embraced uncertainty. Where we search for measurement, they search for meaning. Each myth, whether from Babylon, India, Greece, Egypt, or the Norse lands, offered not an explanation, but a story, a way of taming the terror of time with symbols and gods. And yet, beneath the beauty of these myths lies a haunting tension. If time is cyclical, then are we trapped in endless repetition? If time is governed by gods, then do we have any control? If time is destined to end in fire or flood, then what is the value of each fragile moment we live? These questions did not remain in the temples or the stories. They seeped into daily life, shaping how people lived, how they built, how they worshipped. Farmers planted by the rhythms of the stars, kings ruled by the cycles of prophecy, and entire civilizations rose and fell under the weight of their understanding of time. The mystery deepens when we contrast these myths with the modern notion of time as linear. Today, we see time as a straight arrow, shot from the past toward the future. But the ancients remind us that this is not the only way to imagine existence. Their fractured visions, cycles, battles, opportunities, destructions, offer us a mirror to our own uncertainty. For as advanced as our science has become, the same questions remain. Does time repeat? Does it end? Can it split into alternate paths? Or are we bound to a single, fragile thread? The section ends where it began, with the imagery of stories carved in stone and stars traced across the sky. Ancient myths do not give us equations or evidence. Instead, they give us images powerful enough to last thousands of years. An hourglass may fracture, but in these myths, time was always fractured already, divided between cycles and ends, gods and fates, chaos and order. These stories still whisper to us today, not as relics of superstition, but as echoes of humanity's oldest confrontation with mystery. We have always lived in the shadow of time, and from the beginning, we have asked the same question: is this path fixed, or does it fracture into many? The 20th century dawned with a clockwork certainty. The universe was imagined as a vast machine, every gear turning in harmony, every effect following a cause with mathematical precision. Time itself was thought to be absolute, a steady background against which the events of the cosmos unfolded. This view was comforting, even majestic, a universe governed by laws so strict they seemed eternal. But then came Albert Einstein, a quiet man with unassuming presence, who shattered this vision with a stroke of thought. What he introduced was not just a new theory of physics, it was a revolution of imagination. In 1905, Einstein published his special theory of relativity, and with it, time was forever transformed. He revealed that time is not universal, not fixed, not the same for all observers. Instead, time bends, stretches, and contracts depending on speed and motion. Two people, standing in different states of motion, might live in two different versions of time, their seconds ticking at different rates. The steady march of time, once considered unbreakable, became fluid. This idea was shocking, almost unthinkable, and yet it explained phenomena no other theory could. The famous thought experiment of the twin paradox captures this new world. Imagine two twins. One stays on Earth while the other travels on a spaceship near the speed of light. When the traveling twin returns, they are younger than their sibling who stayed behind. The flow of time itself has diverged between them, fractured not by magic, but by the deep geometry of the universe. This was not science fiction. It was reality, confirmed again and again by experiments with atomic clocks flown on airplanes or GPS satellites that must correct their time because they orbit the Earth at incredible speeds. The fracture of time was no longer a myth. It was a measurable fact. But Einstein did not stop there. In 1915, with his general theory of relativity, he went further, weaving time into the very fabric of space itself. Space and time, once thought separate, were revealed to be one continuous fabric, space-time. Massive objects like stars and planets bend this fabric, and time itself slows down near these gravitational giants. This discovery reshaped not only science, but the imagination of humanity. Time was not absolute. It was local, elastic, malleable. It could flow faster or slower, depending on where you stood in the cosmic web. The comforting certainty of Newton's universe was gone. The imagery of this revelation is cinematic. Imagine space-time as a great invisible sheet stretched tight. Place a star upon it, and the sheet bends, curving the paths of planets around it. But what is often forgotten is that time bends too. Near a black hole, where gravity crushes space-time into a funnel of infinite depth, time slows nearly to a halt. An astronaut falling into that abyss could experience minutes, while centuries pass for the rest of the universe. Time fractures at the edge of the event horizon, creating a terrifying divide between observers. What is a single moment for one could be an eternity for another. This idea of relative time stirs both wonder and dread. On one hand, it gives us visions of interstellar travel, of escaping the limits of human life. On the other, it confronts us with a universe far stranger and less predictable than we ever imagined. The orderly ticking of the cosmic clock has been replaced by a fractured symphony, where each observer carries their own rhythm, their own private time. The revolution Einstein began did not just rewrite textbooks. It shattered the very foundation of human certainty. And yet, there is beauty here too. Relativity revealed a universe alive with mystery, where time itself is a participant, not a passive backdrop. It connected the smallest details of daily life, like the GPS signals guiding our phones, to the grandest structures in the cosmos. Without Einstein's corrections, our navigation systems would fail within minutes, leading us astray. The bending of time is not an abstract curiosity. It is woven into our lives, silently correcting our journeys. The fractured hourglass has become practical. Philosophically, Einstein's ideas also shook the human mind. If time is relative, then what does that mean for the idea of now? There is no universal present, no shared moment binding the cosmos together. Two observers, moving differently, may disagree on the order of events, and both would be correct. Past, present, and future are no longer absolute. They depend on perspective. This undermines the very way humans experience existence. If now is not universal, then perhaps all moments exist at once, frozen in the fabric of space-time, waiting only to be experienced. Here lies one of the great paradoxes of Einstein's revolution, the block universe. Many interpretations of relativity suggest that time is like a vast four-dimensional structure, where every moment, birth, death, history, and future, is already inscribed. We're simply moving through it, like characters in a novel flipping from page to page. This vision strips time of flow, making it static, eternal, and complete. To some, this is deeply unsettling, reducing free will to illusion. To others, it is comforting, suggesting that no moment is ever truly lost, that everything we love and fear is preserved forever in space-time. Einstein himself resisted some of these interpretations, preferring to focus on the elegance of the mathematics rather than the philosophy. But the questions linger. Does relativity mean that the future is already fixed, and we're powerless to change it? Or does the very act of experience carve new pathways through space-time, branching into alternate timelines? The revolution Einstein began left these mysteries unresolved, hanging like stars just beyond reach. The cultural impact of this revolution cannot be overstated. Relativity transformed not only science but art, literature, and cinema. Writers and filmmakers seized on the idea of fractured time, weaving it into stories of time travel, alternate realities, and paradox. From science fiction epics to philosophical essays, the ripple of Einstein's thought expanded far beyond physics. It gave voice to the deepest human desire, to escape the tyranny of time, to bend it, to rewrite it. And yet, it also deepened our fear. What if time is stranger than we can bear to imagine? As this section closes, the audience is left in the wake of Einstein's transformation. The steady clockwork universe has crumbled. In its place lies a cosmos where time fractures under speed and gravity, where now has no universal meaning, and where every observer carries their own rhythm. The imagery of the hourglass returns here, but no longer intact. Its sands fall in different streams, depending on where you stand, depending on how you move. The fracture is no longer a myth or a metaphor. It is the very structure of reality. And yet, even this revolution may not be the final word. Einstein's theories, as powerful as they are, leave questions unanswered. What happens when relativity collides with the quantum world, where uncertainty rules and particles dance in impossible ways? Can time fracture even further into countless alternate pathways? Or does Einstein's block universe suggest that everything is already written? These questions linger, waiting in the shadows of the next chapter. Picture a hall of mirrors, endless in every direction. Each reflection appears identical at first, but as you look closer, subtle differences emerge. An angle shifted, a face altered, a scene reshaped. This is the imagery many scientists use to describe the idea of the multiverse, an infinite expanse of realities, branching, reflecting, and refracting, each one a version of existence. Within this hall of mirrors lies the possibility that time itself does not simply march forward along one unbroken path, but fractures into countless diverging streams. The multiverse is not only a theory of worlds, it is a theory of time. The roots of this idea lie in quantum mechanics, the strange science of the very small. Unlike the predictable motions of planets or pendulums, particles at the quantum level behave in ways that defy logic. They can exist in multiple states at once, a phenomenon known as superposition. An electron is not here or there. It is both, until observed. Schrödinger's famous thought experiment of the cat in the box captures this mystery. The cat is alive and dead simultaneously until the box is opened. But if this is true on the scale of particles, then what about the scale of worlds? If a single particle can be in multiple states, could the universe itself split into multiple realities, each containing a different outcome? This idea gave rise to the many-worlds interpretation, one of the boldest visions in modern science. According to this theory, Every possible outcome of every quantum event actually happens, but in separate universes. Flip a coin, and in one universe it lands heads, in another tails. Say a word, and in one universe it changes a life, in another it is swallowed in silence. Each choice, each chance, fractures the flow of time into countless branches. The universe is not singular, but a tree of endless divergence. The cinematic imagery is staggering. Imagine standing at a crossroads, and with every step, infinite versions of you walk down every path simultaneously. One version turns left, another right, another hesitates and stays still. In one reality, you take a risk, in another you play it safe. The multiverse suggests that all of these versions exist, living out every possible story you could have lived. This is at once liberating and terrifying. Liberating, because it suggests no choice is ever lost. Terrifying, because it implies you are not unique. There are infinite yous, infinite versions of every moment, splintered into alternate pathways. Science fuels this vision, but it also struggles with it. Critics argue that the many worlds interpretation multiplies realities without proof, creating an infinite extravagance of universes with no way to confirm their existence. Yet its defenders say it is the most elegant explanation of quantum mechanics, requiring no collapse of the wave function, no mysterious role of the observer. It simply takes the equations seriously. If the math says multiple outcomes exist, then they all must exist, just not in the same universe. But the multiverse is not only a scientific idea. It is a philosophical and emotional bombshell. If every choice creates a new timeline, then what becomes of responsibility? If in one world you succeed and in another you fail, which version is truly you? Do you exist as a single consciousness, or are you fractured across infinite selves, each unaware of the others? And if all possible worlds exist, does free will mean anything at all? Or are we merely passengers, carried along by every possibility simultaneously? These questions reveal the unsettling paradox of the multiverse. It offers infinite freedom, but also infinite futility. In a universe where every choice is made somewhere, does any single choice matter? Does love lose its meaning if, in another universe, you never met the person you cherish? Does tragedy lose its sting if, in another world, the disaster never happened? Or is meaning heightened by the very fragility of our experience, knowing that this version of reality, though one among infinite, is the only one we can ever touch? The imagery of diverging rivers helps to capture this paradox. Picture a single river splitting into countless streams, each carrying its own current, each flowing into unknown seas. Standing at the fork, you see the water diverge, but once it flows away, you cannot follow. You remain on one stream, carried helplessly forward, even as infinite other rivers rush past, invisible but real. The multiverse, in this sense, is not only a theory. It is a haunting metaphor for the choices and chances that shape our lives. The multiverse also appears in cosmology, where physicists imagine vast bubbles of universes expanding within a larger cosmic foam. Our universe may be one bubble among infinite others, each with its own laws of physics, its own flow of time. Some bubbles may collapse instantly, others may expand forever. Some may allow stars and life, others may be empty voids. In this cosmic multiverse, time itself may fracture differently in each universe, flowing in ways utterly alien to our perception. One universe might see time as cyclical, another as static, another as chaotic. The diversity is beyond imagination. Culturally, the multiverse has captivated the human imagination. From ancient myths of branching destinies to modern films exploring alternate realities, the idea of fractured time resonates deeply with us. Perhaps it is because we live with regret and longing, wondering what might have been if a single decision had gone differently. The multiverse takes that longing and amplifies it to infinity. It whispers that those alternate lives do exist, but just beyond reach. Every what if you have ever imagined may play out somewhere, in some fractured thread of time. And yet, this vision comes with a warning. The multiverse could strip meaning from reality, reducing our lives to one possibility among countless trivial variations. It could paralyze us with the thought that nothing is final, nothing is unique. But it could also inspire us, reminding us that in this universe, on this path, we have the rare gift of experience. This version of you, watching this story, exists only once. The sands of the fractured hourglass scatter in infinite directions, but the handful you hold now is yours alone. As the section closes, the audience is left suspended between awe and unease. The multiverse offers both liberation and terror, both infinity and insignificance. It is a mirage, dazzling, endless, but always just beyond reach. Scientists argue about its reality, philosophers wrestle with its meaning, and storytellers spin its visions into myth. Whether true or not, the multiverse forces us to confront the fragility of our own reality, the haunting possibility that time fractures not once, but endlessly. The hall of mirrors remains before us, each reflection a different life, a different world, a different stream of time. The question lingers: are we gazing into illusions, or are we already standing among them, fractured into infinite versions of ourselves? The answer lies hidden in the shimmering depths of the mirage, waiting for us to step closer. Long before equations tried to tame it and telescopes sought to measure it, philosophers wrestled with the ghost of time. Unlike stars or stones, time cannot be touched, weighed, or seen. It is the stage on which everything unfolds, and yet it slips through the fingers of reason like water. From the temples of ancient Rome to the quiet studies of modern Europe, the greatest thinkers have argued, feared, and wondered about the same enigma. What is time, and does it truly exist? Their words, scattered across centuries, form a chorus of mystery that still resonates today. Take St. Augustine, one of the early voices in this debate. Writing in the 4th century, he confessed in his Confessions, "What then is time? If no one asks me, I know. If I wish to explain it to one who asks, I know not." With this single sentence, Augustine exposed a truth that echoes through philosophy. We live immersed in time, and yet when we try to define it, it dissolves. Augustine believed that past and future do not exist in themselves. The past is memory, the future is expectation, and only the present is real. But then he asked, what is the present? The moment we try to seize it, it vanishes into the past. Time, for Augustine, was both intimate and elusive, real and unreal at once. Centuries later, Immanuel Kant offered a radically different vision. For him, time was not something out there in the universe, but something inside us. He argued that time is a form of human perception, a lens through which we experience reality. Just as our eyes perceive the world through the structure of vision, our minds perceive events through the structure of time. This meant that time is not an independent entity, but a framework of consciousness. Without the mind to perceive it, Kant suggested, time might not exist at all. This view shook the foundation of certainty. If time is a construct of perception, then reality itself is deeply subjective, filtered through the architecture of thought. Then came Martin Heidegger, who shifted the conversation from abstract theories to the human experience of existence. In his monumental work, Being and Time, he argued that time is not a distant cosmic clock, but the very condition of being human. We live in anticipation of the future, haunted by the inevitability of death, and this anticipation shapes every decision we make. Time, in this sense, is not a neutral background. It is the essence of human anxiety and meaning. For Heidegger, to exist is to be thrown into time, to live within a finite horizon that makes every moment urgent. His vision of time was not mechanical, but existential, a fractured mirror of hope and dread, freedom and inevitability. Other thinkers added their own fragments to this puzzle. Aristotle, in the ancient world, described time as the number of motion according to before and after. For him, time was inseparable from change. Without movement, without events, there would be no time. Centuries later, Henri Bergson challenged this with the idea of duration, a flowing, qualitative experience of time that cannot be reduced to numbers on a clock. Bergson contrasted scientific time, measured and dissected, with lived time, rich with emotion and memory. The difference between a second on the clock and a second in grief or joy, he argued, reveals a deeper truth. Time is not uniform but experienced. These contrasting visions reveal the central paradox of philosophy's pursuit of time. On one side, time appears as an objective structure, measurable, universal, the same for all. On the other, it appears as a subjective experience, fluid, personal, fractured by memory and anticipation. This tension has never been resolved, and perhaps it never can be. Each thinker touches a different side of the same prism, illuminating it with brilliance, but never grasping the whole. The imagery of their struggle is cinematic. Imagine a library stretching into infinity, its shelves lined with volumes from every age. Each philosopher enters, writes their vision of time, and leaves. Augustine writes of the vanishing present, Kant of the mind's lens, Heidegger of the anxious horizon, Bergson of flowing duration. Each book contradicts and complements the others, and yet together they form a mosaic of awe and confusion. As you walk through the library, you realize the books themselves are part of the puzzle. For the moment you finish reading one, it belongs to the past, while the next waits in the future. Even the act of seeking time is bound by time. Emotionally, this philosophical struggle leaves us both enlightened and unsettled. On one hand, it reassures us that the mystery of time is not ours alone. Humanity's greatest minds have failed to tame it. On the other, it deepens our unease, showing us that time may be stranger than any single definition. Is it an illusion, a construct, a cosmic rhythm, or the very essence of being? Each answer opens more questions. Each resolution fractures into more uncertainty. The narrative purpose of this section is to bridge the gap between myth and science. Ancient myths gave time gods and cycles. Modern physics bends it with gravity and speed. Philosophy stands in the middle, where logic meets wonder, and reveals that the puzzle of time is not only physical, but also metaphysical. It forces us to ask not only how time works, but what it means. And meaning, unlike mathematics, is never absolute. As this section closes, the audience is left with the haunting realization that time has always escaped definition. It is both stage and actor, both illusion and reality, both the measure of change and the essence of existence. Augustine's confession lingers like an echo. We live inside time, but we do not know what it is. And perhaps that ignorance is not a failure, but the very point. For to live in time is to live in mystery, carried forward by a current we cannot see, yet cannot escape. When humanity first began to measure, it was not stars or seas that carried the greatest urgency, but time itself. To hunt, to farm, to survive, people needed a way to predict the rhythms of day and night, season and storm. What began as mythic cycles soon hardened into mathematics, giving birth to the earliest physics. Time, once the domain of gods and spirits, became something that could be charted, divided, and, most importantly, controlled. From this need emerged the foundations of temporal order, the bedrock upon which all science was built. The ancients turned their eyes skyward. The motion of the sun and moon became their first clock, their steady arcs the metronome of existence. Sundials carved shadows into stone, transforming celestial movement into earthly numbers. For the Egyptians, the flooding of the Nile was not a mystery, but a pattern tied to the rising of Sirius, the dog star. They built calendars not only to predict harvests, but to synchronize society itself. Time was now a shared rhythm, binding individuals into a collective order. Greek philosophers advanced this search for order with bold abstractions. For Aristotle, time was inseparable from motion. He wrote that time is the number of motion according to before and after, a definition that reduced the flowing mystery of duration into a measurable sequence. Time, in his view, was not a thing in itself, but a way of counting change. This idea, time as measurement, would echo through history, finding new voices in Galileo's swinging pendulums and Newton's ticking clocks. The transition from philosophy to physics crystallized in the Renaissance. Galileo, standing in the Cathedral of Pisa, is said to have watched a swinging chandelier and realized its motion could be regular, predictable. By timing its swings against his own pulse, he glimpsed a new truth. Nature itself obeyed hidden rhythms that could be uncovered. Time became not a vague experience, but a precise quantity. With this revelation, Galileo transformed time into the silent partner of mathematics. His experiments rolling balls down inclined planes linked motion to intervals, giving birth to the modern science of dynamics. Then came Newton, who carried Galileo's vision into a vast, all-encompassing system. To Newton, time was absolute. It flowed evenly, inexorably, the same for every place, every object, every observer. This conception turned time into a universal backdrop, a stage on which the drama of the cosmos unfolded. Whether a falling apple or a spinning planet, the laws were the same, and the clock that measured them ticked with perfect indifference. The Newtonian view created an illusion of certainty, a clockwork universe wound tightly by divine hands and left to run. But hidden within this triumph was a quiet fracture. Newton's time was external, mechanical, and human. It was the opposite of Augustine's vanishing present or Bergson's lived duration. In the Newtonian cosmos, time cared nothing for perception or meaning. It was an arrow pointing forward, indifferent to memory or hope. Yet for all its coldness, this vision proved astonishingly effective. It allowed engineers to build machines, navigators to cross oceans, astronomers to predict eclipses. Time had been captured by science, and the world itself seemed more controllable because of it. The emotional contrast here is sharp. Imagine the awe of those early scientists, their quills scratching out formulas that revealed the hidden gears of creation. For the first time, humanity had the sense that the universe was not chaos but order, an intricate design waiting to be uncovered. And yet, beneath this triumph lay unease. If time was a mechanical flow, did human experience matter? Was memory merely a trick of the brain? Anticipation a chemical illusion? The certainty of physics seemed to strip away the intimacy of lived time. Still, progress demanded this sacrifice. Sundials gave way to pendulum clocks, pendulums to gears, gears to quartz oscillators, and eventually to atomic vibrations. Each step tightened humanity's grip on temporal order. Factories synchronized laborers to whistles and bells. Trains connected cities by timetables. Telegraphs and later radio demanded clocks that agreed across continents. Time was no longer local but global, no longer fluid but standardized. The world itself became a mechanism bound by uniform seconds, minutes, and hours. In this way, the birth of physics and the conquest of temporal order reshaped civilization. Time turned from mystery into infrastructure, the invisible architecture holding up economies, empires, and entire ways of life. What once belonged to gods now ticked inside every pocket watch, every factory clock, every naval chronometer guiding ships across uncharted waters. Humanity had subdued time, or so it seemed. Yet even in this golden age of certainty, cracks remained. The Newtonian vision could not explain everything. Light, with its stubborn constancy, resisted the neat formulas. Gravity, though precise, carried mysteries that whispered of deeper truths. The ordered world of absolute time was magnificent, but fragile, waiting to be shattered by the next great revolution. This section closes with a lingering sense of suspense. The triumph of physics gave us mastery, but at a cost. It alienated us from the intimate, subjective flow of time. The clock ruled, but the mystery endured. Beneath the ticking order lay unanswered questions, silent fractures waiting to split open. The audience is left with a dual vision: humanity as master of time, yet also prisoner of its deeper enigma. What seemed fixed and absolute may, in the chapters ahead, reveal itself to be anything but certain. For centuries, Newton's vision of absolute time reigned supreme. The universe was imagined as a grand clock, its gears turning with mechanical precision, its moments flowing uniformly from past to future. Time was steady, impartial, unshaken by the events it measured. But in the early 20th century, one quiet, unassuming man, Albert Einstein, walked into the halls of physics and shattered that clock. With pen and paper alone, he cracked open the illusion of absolute time and revealed a cosmos far stranger, more flexible, and more terrifying than anyone had imagined. Einstein's insight began not with time itself, but with light. Scientists already knew that light behaved in mysterious ways. No matter how fast one moved toward or away from it, light's speed remained the same. This fact defied Newton's orderly world, where velocities were supposed to add or subtract. If you threw a ball on a moving train, its speed combined with the train's. Why then did light refuse to obey? Why did it act as though the universe bent its rules for its brilliance? Einstein's answer was radical. The problem was not with light, but with time and space themselves. In 1905, his theory of special relativity declared that time is not absolute, but relative. The faster you move, the slower time flows for you compared to someone at rest. A clock racing at near-light speeds ticks more slowly than one standing still. Time, that supposed universal constant, could stretch or contract depending on your journey. The implications were staggering. Imagine two twins. One remains on Earth. The other travels into space at near-light speed and then returns. The traveling twin will have aged less than the one who stayed behind. This so-called twin paradox was not a fantasy, but a logical consequence of relativity. Time was no longer a fixed river flowing for all alike. It was a personal current, unique to each observer, sculpted by their motion through space. But Einstein's revolution did not end there. A decade later, he unveiled his general theory of relativity, a vision even more breathtaking. Gravity, he proposed, is not a force pulling objects together, but the warping of space and time. Massive bodies like stars and planets bend the very fabric of reality around them. And within that bend, time itself slows. A clock near a massive planet ticks more slowly than one far away. Time and space were no longer separate entities. They were a woven fabric, a single continuum called space-time, pliable and dynamic. The imagery here is almost cinematic. Picture a rubber sheet stretched taut. Place a heavy ball in the center, and the sheet curves downward. Smaller balls rolling nearby, spiral inward, trapped in the curve. This is the visual metaphor often used to explain Einstein's universe. But beneath this simple picture lies a profound truth. We do not live in a stage called space and time. The stage itself bends, ripples, and flows. We are not actors on an unchanging platform. We are woven into the fabric of reality itself. Einstein's theories did more than rewrite textbooks. They rewrote the imagination of humanity. Time dilation, gravitational warping, space-time curvature. These concepts sound abstract, but they have been tested, measured, and proven. Satellites orbiting Earth must account for both special and general relativity. Their onboard clocks tick differently than those on the ground. Without correcting for this warping of time, GPS navigation would be hopelessly inaccurate. Every time we check our phones for directions, we are unknowingly relying on Einstein's fractured vision of time. The emotional impact of this discovery was immense. On one hand, it was exhilarating. The universe was richer and more wondrous than Newton had dared to dream. Time itself could bend. On the other, it was unsettling. If time is not absolute, then our sense of a shared, universal now is an illusion. Two events that appear simultaneous for one observer may not be simultaneous for another. Reality is fractured, relative, depending on where you stand and how you move. The very notion of an objective present dissolves under Einstein's equations. This realization raises haunting questions. If there is no universal now, then what does it mean to say something is happening? Are past, present, and future equally real, lying frozen in space-time, waiting to be observed? Or is time still somehow flowing, despite relativity's indifference to such motion? The answers are elusive, but the emotional weight is clear. Einstein's revolution did not just bend clocks and rulers. It bent the human soul, shaking the foundation of how we understand existence itself. The contrast framing here sharpens the narrative. For Newton, time was a rigid, eternal flow. For Einstein, it became malleable, fragile, and local. One vision offered certainty, the other revealed relativity. The tension between these two worlds mirrors our own struggle. The comfort of believing in a stable reality versus the awe of confronting a fractured one. Einstein himself felt the weight of this paradox. He once described the distinction between past, present, and future as a stubbornly persistent illusion. For him, the block of space-time existed all at once, timeless and eternal, with our perception of flowing time merely a trick of consciousness. To live, then, is to travel along a fixed pathway through a fabric already woven. It is a vision at once liberating and terrifying. If the future already exists, what does it mean to choose? If the past never truly vanishes, what does it mean to forget? The legacy of Einstein's revolution lingers everywhere. In science, it opened the door to black holes, wormholes, and the expanding universe itself. In philosophy, it forced thinkers to confront a reality where time might not flow at all. In art and culture, it inspired visions of fractured timelines, alternate realities, and journeys beyond the speed of light. Einstein's relativity did not just alter physics, it changed how humanity dreams. As this section closes, the audience is left at a precipice. Time, once thought absolute, is revealed as elastic, personal, and warped by gravity itself. The universe no longer ticks like a perfect clock. It stretches and bends like a living fabric. And yet, even this dazzling revolution may not be the final truth. For just as Einstein shattered Newton, new questions arise that may one day shatter Einstein himself. The warping of time is wondrous, but the mystery of time remains. In the grand theater of Einstein's warped space-time, black holes emerged not just as astronomical curiosities, but as the most extreme laboratories of time itself. Born from the collapse of massive stars, these cosmic abysses are regions where gravity grows so overwhelming that even light, the swiftest traveler in the universe, cannot escape. Their very existence stretches the human imagination, but it is their relationship with time that carries the most haunting revelations. Black holes do not merely distort space. They twist, slow, and fracture time until the concept itself begins to unravel. Imagine drifting near the event horizon, the boundary that marks the point of no return. To a distant observer, your descent appears to slow. The closer you get, the slower your clock ticks compared to theirs. From a perspective, you seem to freeze in place at the edge, never quite crossing. Time for you, however, feels normal, your heartbeat steady, your breath calm. But in the universe beyond, centuries could pass in the span of your final seconds. This is gravitational time dilation at its most extreme, where different observers inhabit realities separated not by distance, but by the flow of time itself. Here, the imagery sharpens into something surreal. Picture a spacecraft hovering near a black hole, one astronaut daring to descend, while another remains at a safe distance. The one who falls would live mere minutes before destruction, while the other might watch entire eras unfold in the blink of an eye. Empires could rise and collapse, stars could ignite and die, all while the doomed explorer experienced nothing more than fleeting moments. Time itself, once thought universal, fractures at the edge of the abyss. This paradox deepens at the singularity, the heart of the black hole, where all known laws of physics collapse. Here, according to Einstein's equations, density becomes infinite, and time itself ceases to have meaning. The singularity is not merely a point in space. It is the breakdown of space and time altogether. What lies beyond it is unknowable, a realm hidden from observation, locked away by the event horizon. The singularity represents not just the death of a star, but the death of our ability to describe reality. Black holes expose the terrifying contrast between human perception and cosmic truth. To us, time feels steady, a dependable rhythm guiding our lives. Yet near these monsters, that rhythm fractures into discordant beats. For one observer, moments stretch into eternities. For another, eternities collapse into moments. In their presence, time ceases to be a shared experience. It becomes personal, local, distorted, a reminder that our lives unfold within a fragile illusion of stability. And yet, the mystery does not stop at terror. Black holes may also conceal pathways to possibilities that border on the fantastical. The mathematics of Einstein's relativity allows for wormholes, tunnels that could connect distant points in space-time. If black holes are one end of such a tunnel, then perhaps somewhere else in the cosmos lies a white hole, an object that expels rather than consumes. Could these cosmic gateways allow us to leap across galaxies, or even traverse time itself? The speculation remains unproven, but the possibility has captured both physicists and dreamers alike. The emotional weight here lies in the duality of hope and dread. On one side, black holes are monsters, cosmic graves that swallow stars and trap time itself. On the other, they may hold the key to deeper truths, perhaps even to time travel. This contrast electrifies the imagination. What humanity fears most might also conceal what it longs for most, the ability to escape the prison of linear time. Black holes also challenge our notions of information and memory. According to classical physics, anything that falls into a black hole is lost forever. But modern theories, particularly those involving quantum mechanics, suggest otherwise. Stephen Hawking famously argued that black holes radiate energy, Hawking radiation, which could eventually cause them to evaporate. If this is true, what happens to the information about everything they swallowed? Is it erased from the universe, or is it somehow encoded in the radiation? This information paradox is more than a technical debate. It is a philosophical wound. If information can be destroyed, then the universe itself may not be coherent. If it cannot, then black holes may be the strangest of libraries, storing the imprints of everything they consume. The narrative purpose of this section is to push the audience to the very edge of comprehension. Black holes reveal that time is not a simple current, but a fragile thread, stretched and torn under cosmic weight. They remind us that the universe is not built for human intuition. Our clocks, our calendars, even our philosophies tremble when faced with the abyss. And yet, these same abysses may conceal the answers to questions that haunt us. Is time finite or infinite, linear or cyclical, absolute or relative? Visually, the section evokes awe and dread. The warped light circling a black hole, the infinite darkness of its core, the strange freezing of falling matter. These images are cinematic not only for their beauty, but for the existential weight they carry. To stare into a black hole is to stare into the fractures of time itself, into the limits of knowledge, into the abyss that swallows certainty. As this section draws to a close, the audience is left suspended at the event horizon. Black holes have shown us that time can stretch, slow, and collapse, that our universe is stitched together by fragile laws that bend under extreme pressure. Yet the ultimate question remains, what lies beyond? Does time end at the singularity, or does it begin again in forms we cannot yet imagine? The mystery is not only scientific, it is deeply human. For as long as black holes exist, they will be mirrors of our own fear and wonder, reminding us that time is not only fractured, but perhaps unknowable. If Einstein fractured the certainty of Newton's clockwork universe, quantum mechanics shattered it into pieces so small and strange they often defy belief. At the quantum scale, the realm of atoms, particles, and probabilities, time reveals itself not as a steady flow, but as a flickering uncertainty. It becomes something granular, unstable, and almost dreamlike, where cause and effect blur, and the very meaning of before and after is called into question. If relativity bent time into curves, quantum theory dissolves it into mist. To understand this shift, imagine a particle, an electron, tiny and elusive, dancing within an atom. Classical physics would expect it to have a definite position and velocity at any moment. But quantum mechanics says otherwise. The Heisenberg uncertainty principle declares that we cannot know both perfectly at once. The more precisely we measure one, the less precisely we know the other. Applied to time, this principle reveals a haunting truth. The flow of events itself is probabilistic. The ticking of the quantum world is not steady like a metronome, but stuttering, ghostly, hidden behind veils of probability. At this scale, time is not a river, but a haze. A particle can exist in a superposition, occupying multiple states at once, until an observation forces it into one. In such a world, what does it mean to say an event happened at a specific time? If a particle can be both decayed and undecayed, both here and there, then the sequence of reality becomes slippery. Time in the quantum realm is not the ordered succession we live by. It is fractured possibility, a dice game written into the fabric of existence. Quantum entanglement deepens the mystery. Two particles, once linked, remain connected no matter how far they are separated. Measure one, and the other responds instantly, as though distance and time mean nothing at all. This spooky action at a distance, as Einstein derisively called it, violates the common sense notion that cause must precede effect within a shared temporal framework. If entangled particles can influence one another outside the limits of time, then perhaps time itself is not a fundamental feature of reality, but an emergent one, a shadow cast by deeper, timeless laws. In this light, physicists have begun to question whether time exists in the way we imagine. Some interpretations of quantum mechanics suggest that time may be an illusion, an emergent phenomenon arising from correlations between events rather than an underlying flow. In other words, the ticking we perceive may be a byproduct of relationships among particles, not a universal metronome. The idea is as chilling as it is awe-inspiring. Time may not be the foundation of reality, but a fragile construct built on deeper, hidden structures. One of the most dramatic ways this plays out is in the quantum concept of time reversal symmetry. At the microscopic level, the equations describing particles work just as well backward as forward. Unlike our lived experience, where glasses shatter but do not reassemble, quantum laws do not prefer direction. A process can unfold forward or backward with equal legitimacy. This suggests that the arrow of time, the one-way street from past to future, may not be fundamental. It may be an illusion born of entropy and observation. In the deepest equations, time does not flow, it hovers in symmetry. Yet, here lies the emotional contradiction. Our lives are lived in the grip of time's arrow. We age, we remember, we anticipate. The quantum world, however, whispers that this arrow may be parochial, an artifact of scale, not an absolute truth. What would it mean if at the most basic level of reality, time has no preference, no flow, no distinction between before and after? It would mean that the reality we experience is not reality itself, but a projection, a story told by entropy and perception. The imagery becomes dreamlike here. Picture a vast casino where the dice never stop rolling. Each toss creates not one outcome, but many, branching into possibilities that coexist in a haze until someone looks. This is the stage of quantum time, not a single pathway, but a fractured forest of maybes. To live in such a world is to realize that the stability of now is an illusion, a fragile consensus of probabilities collapsing into coherence. Some physicists have even proposed models where time itself quantizes, coming in indivisible units like grains of sand. If space is composed of quanta, perhaps time is too, not infinitely divisible, but pixelated at unimaginably small scales. If so, then the flow we perceive is not smooth, but granular, like a film reel, flickering frames so quickly that the illusion of continuity appears. Our lives, then, may be woven not from a continuous river of time, but from countless tiny jolts stitched together by perception. The narrative purpose of this section is to drag the audience deeper into unease. Relativity fractured our universal now, but quantum theory obliterates even the stability of cause and effect. It forces us to confront the possibility that time is not a cosmic constant, but a convenient illusion. What we trust most, the ticking clock, the unfolding of moments, may be nothing more than a trick of the quantum haze. Emotionally, the impact is profound. All mixes with dread. On one hand, quantum time reveals a universe so strange it exceeds imagination, a place where particles blur across timelines, where distance and delay vanish into entanglement, where reality itself resists certainty. On the other, it robs us of the comfort of flow, the narrative of before and after that anchors human meaning. Without time, what becomes a memory? Without time, what becomes of choice? As this section closes, the audience is left hanging in uncertainty itself. Time, once thought absolute, was fractured by Einstein. Now, at the quantum scale, it dissolves altogether. We are left with a paradox. We live by time, yet the deepest laws of reality may not require it at all. The mystery grows heavier, the questions sharper. Was time if not real? And if time is only a story, who or what is telling it? Every human instinct tells us that time moves forward. We watch the sun climb the horizon, then sink. We see children grow into adults, never the reverse. A broken glass shatters on the floor, but never leaps back whole into our hands. This one-way direction, the arrow of time, feels like the most natural truth. Yet physics reminds us that this truth is not so simple. The deeper we peer, the more we realize that the arrow of time is bound not to some universal law, but to a single haunting principle: entropy. Entropy is the measure of disorder, a silent current pulling everything toward chaos. It is the reason ice melts but never refreezes itself spontaneously, the reason smoke disperses but never gathers back into a neat column. The second law of thermodynamics declares that in a closed system, entropy always increases. This is not just a rule of physics. It is the heartbeat of the arrow of time. The universe itself drifts inevitably toward greater disorder, and in that drift, we perceive time's forward march. But why does entropy define direction when most of physics does not? At the microscopic level, the laws of motion are time-symmetric. They work equally well forward or backward. A film of colliding billiard balls, played in reverse, looks just as plausible as one played forward. Yet on the macroscopic scale of daily life, reversals never happen. The answer lies in probability. There are far more ways for a system to be disordered than ordered. A deck of cards perfectly sorted is one in a million possibilities, while shuffled decks number in the billions. Given enough time, systems naturally move from improbable order to probable disorder. This overwhelming imbalance gives rise to the arrow we all feel. Imagine the universe in its earliest moment, the Big Bang. At birth, it was hot, dense, and astonishingly ordered. Out of that improbable order, entropy has been climbing ever since. Galaxies form, stars ignite, life emerges, all temporary pockets of order against the backdrop of increasing chaos. This contrast is the poetry of existence. We live within islands of structure that float on a rising sea of disorder. time moves forward not because the universe demands it, but because the universe began in a low-entropy state and has been unraveling ever since. The emotional resonance here is profound. The arrow of time is not written into the universe like gravity. It is born of imbalance, of an improbable beginning. We march forward because the cosmos began in such exquisite order that disorder became inevitable. The future feels inevitable because it is the pathway of probability, the one direction where entropy grows. Our very memories, the anchor of our identities, are tied to this arrow. Memory exists because entropy increases. We remember the past precisely because information leaves traces, and traces accumulate as order dissolves. Yet entropy brings both comfort and despair. On one hand, it explains why time feels irreversible, grounding our experience in the machinery of physics. On the other, it whispers of a bleak destiny. If entropy always rises, then the universe will one day reach maximum disorder, heat death. In that far-off future, stars will burn out, galaxies will fade, black holes will evaporate, and all motion will cease. Without gradients, without contrasts, without order, time itself may lose meaning. The arrow of time that carries us will one day flatten into stillness. The imagery of entropy's rise can be cinematic. Picture a pristine crystal dropped into acid, its lattice dissolving into chaos. Picture the cosmos itself as an hourglass, grains of order slipping irreversibly into disorder until nothing remains but smooth, uniform dust. Against this vision, human life appears fragile. Our loves, our achievements, our memories are all carved on the slope of entropy, destined to erode. And yet, the very fragility makes them precious. Without entropy, there would be no growth, no evolution, no story. Time's arrow is both destroyer and creator. Philosophically, entropy reframes time as a paradox of hope and despair. On one side, the arrow grants us narrative, beginning, middle, and end. It gives us memory, progress, and meaning. On the other, it makes everything transient, dooming even the brightest stars to fade. This duality mirrors the human condition. To live is to advance toward disorder, yet to resist it with moments of fleeting order. Every act of creation, from art to love to science, is a defiance of entropy, a rebellion against the march of time. But deep questions remain. Why did the universe begin in such low entropy? What primordial condition set the arrow in motion? If entropy is probability, then why was the improbable chosen at the start? These questions remain unanswered, hanging like shadows over cosmology. The arrow of time may feel absolute, but its origin remains mysterious, hidden behind the veil of the Big Bang. This uncertainty sharpens the contrast of the narrative. Relativity revealed time's relativity. Quantum mechanics dissolved its flow, but entropy anchors it with a single direction. And yet, even this anchor trembles. If entropy defines time's arrow, and entropy itself is born of initial conditions we cannot explain, then perhaps even the arrow is not fundamental. Perhaps time's flow is not the iron law we imagine, but another illusion spun by beginnings we do not yet comprehend. As this section closes, the audience stands at a threshold of wonder and dread. Entropy explains the inevitability of change, the one-way march of time, the reason we remember but cannot unremember. It also reveals a destiny of eventual stillness, a future where the arrow itself may vanish. The arrow of time is both our compass and our cage, defining every moment we live while pointing toward an end we cannot escape. At the smallest scales of existence, time no longer resembles the smooth and steady arrow we take for granted. Instead, it flickers with uncertainty, dissolves into probabilities, and bends to the strange laws of quantum mechanics. Here, the familiar story of past, present, and future collapses. Time ceases to be a single flowing river and begins to resemble a vast ocean of branching waves. each crest a possibility, each trough a shadow of what might have been. To enter this realm is to step into one of the most daring ideas in science, the multiverse. Quantum mechanics teaches us that particles exist not in definite states, but in superpositions, a blur of possibilities. An electron does not sit in one place until observed. It hovers in many places at once, described by a mathematical wave function. The act of measurement collapses this wave function into one outcome. But until that collapse, multiple realities coexist. This is not just mathematics. It is a riddle about the fabric of reality itself. If multiple outcomes are possible, what happens to the ones we do not observe? Do they vanish into nothingness, or do they persist in unseen branches of time? In 1957, physicist Hugh Everett proposed a radical answer. They persist. Every possible outcome of every quantum event is realized, each in its own branching universe. You flip a coin, and in one universe it lands heads, in another it lands tails. You take one path home, in another you take a different road. Every choice, every accident, every flicker of quantum uncertainty multiplies reality into a vast multiverse. Within this picture, time does not flow as a single arrow, but erupts into endless pathways fracturing at every moment. The emotional weight of this idea is staggering. It suggests that you are not singular but manifold, scattered across countless worlds. In one, you may have succeeded where here you failed. In another, you may never have been born. The multiverse turns life into a library of infinite volumes, each book containing a different story, all written simultaneously. For some, this thought is liberating. Nothing is ever truly lost because in some branch it survives. For others, it is terrifying. Individuality dissolves, and every triumph is haunted by an alternate failure. But what does this mean for time itself? In the multiverse view, time may not be a line, but a tree, trunks splitting into branches, branches splitting into twigs, twigs into leaves. The arrow still points forward within each branch, carried by entropy and memory. But across branches, forward is multiplied into countless directions. Time, then, is not singular but plural, a chorus of arrows rather than one. This branching reality raises unsettling philosophical questions. If all outcomes exist, what does choice mean? Are we free to decide, or do we merely experience one of many predestined splits? Does responsibility survive when every possibility unfolds somewhere? The multiverse challenges not only physics, but morality, meaning, and identity itself. To believe in it is to live with the awareness that our universe is not the only stage, but one among endless variations. Visualize it, a prism catching a beam of light. The white ray enters, then fractures into many colors. Each hue travels forward, parallel yet separate. Our timeline may be no different, one beam fractured into infinite shades of reality. The multiverse is the cosmic prism, splitting the arrow of time into a spectrum too vast for any single mind to see. Yet the multiverse is not a settled truth. It remains controversial, hovering between science and philosophy. Some physicists argue it is the most natural consequence of quantum mathematics. Others dismiss it as untestable speculation, a dreamscape beyond the reach of observation. The mystery deepens when we consider cosmology. Eternal inflation, a model of the universe's birth, suggests not only quantum branching, but entire universes budding endlessly, like bubbles in an infinite froth. In that vision, our cosmos is just one bubble among countless others, each with its own arrow of time, its own laws, its own destiny. This expansion of scale is both awe-inspiring and disorienting. To imagine countless universes alongside ours is to realize how small our timeline truly is. The arrow of time that feels so inevitable may be just one of many, a local rhythm in an infinite orchestra. Perhaps what we call time is only the pattern that emerges within our bubble, while other bubbles follow other songs. some unrecognizable to us. Still, the multiverse offers a profound narrative power. It allows us to hold two contrasting emotions at once: humility and possibility. On one hand, we are insignificant, just one thread in an endless tapestry. On the other, we are infinite, existing in uncountable variations across the branching corridors of time. This contrast grips the imagination, pulling us between despair at our smallness and wonder at our multiplicity. Philosophers, too, have wrestled with these implications. If there are infinite versions of us, is there such a thing as the real you? Or is the self only a temporary arrangement, unique only in the branch it inhabits? The multiverse strips away the comfort of singular identity, replacing it with a dizzying plurality. Yet it also mirrors the way we already live. Every decision closes doors and opens others. Every moment births alternate futures we can never return to. The multiverse takes this human experience of possibility and extends it to the cosmos itself. At the heart of the idea lies the mystery of observation. Why do we experience one branch and not the others? What is it about consciousness that ties us to one timeline while others remain inaccessible? Some argue that the mind itself collapses possibilities, stitching us to a single thread. Others believe the branches are all real, but our awareness cannot split. The question remains unresolved, a philosophical puzzle as much as a scientific one. And so, quantum time and the multiverse hypothesis offer a vision both unsettling and magnificent. They challenge the idea of a single arrow, suggesting instead a forest of arrows diverging endlessly. They dissolve certainty, blur identity, and yet ignite wonder. For every moment we live, infinite other moments branch away, invisible but perhaps no less real. As this section closes, the mystery only deepens. If time itself can fracture, if reality itself can branch, then what does it mean to speak of the future? Is the future a single destination, or an infinity of possible destinations unfolding all at once? The arrow of time, once thought to be singular and steady, may in fact be a kaleidoscope, shattering into endless pathways where every possibility becomes real. What does it mean to choose, if time itself may not be what it seems? For centuries, human beings have lived with the belief that our choices carve the future, that every decision bends the arrow of time in a direction uniquely our own. We wake in the morning believing we could stay in bed or rise to greet the day, believing that in the moment of hesitation lies the power of free will. Yet as science dissects the nature of time, the certainty of that freedom begins to unravel. If the universe is deterministic, unfolding according to physical laws as precise as clockwork, then every thought and every action was encoded in the initial conditions of the cosmos. From the fire of the Big Bang to the neurons firing in your brain at this moment, all of it might have been inevitable. Your decision to listen, to breathe, to believe in freedom, already written before you were born. In this vision, free will is not a power, but an illusion born of ignorance. We feel free because we do not see the chain of causes stretching infinitely into the past. Neuroscience adds fuel to this unsettling possibility. In the 1980s, experiments by Benjamin Libet revealed that the brain shows signs of decision-making milliseconds before a person consciously decides. Later research extended this window to seconds, even predicting choices before they reach awareness. If our brains prepare actions before we decide, then who or what is really in control? Consciousness may not be the author of choice, but the narrator, explaining after the fact what was always going to happen. Now, place this question within a timeless universe. If the block universe model of relativity is true, where past, present, and future exist simultaneously, then the notion of choosing collapses. Every decision already resides somewhere in that four-dimensional structure. The you who chose differently already exists in another part of the block, but you can never access it. The timeline is complete, fixed like ink on parchment. Free will, in such a cosmos, is no more real than a character in a novel choosing their fate. The story is already written. The character only discovers it page by page. Yet the human spirit resists this fatalism. We live as though choice is real because without it, meaning itself begins to disintegrate. If we cannot choose, how do we hold anyone responsible for cruelty or honor anyone for kindness? How do we dream, strive, or love if all is predetermined? The very fabric of morality is woven from the belief that we are free to act otherwise. The illusion of free will, if illusion it is, might be the most necessary fiction humanity has ever embraced. The emotional weight of this paradox grows heavier when contrasted with quantum mechanics. Where determinism paints the cosmos as clockwork, quantum theory seems to add uncertainty, genuine unpredictability at the smallest scales. Yet randomness does not equal freedom. A dice roll may be uncertain, but it is not free. If our choices are only the product of quantum fluctuations, are we truly liberated or simply passengers in a probabilistic storm? Between the iron grip of determinism and the chaos of randomness, freedom struggles to find its place. Still, there are those who argue that free will can survive within these frameworks, not as absolute control, but as emergent complexity. The human brain, with its billions of neurons and trillions of connections, may operate at a level where freedom is not about escaping causality, but about harnessing it. Just as weather patterns emerge from the physics of air molecules, perhaps free will emerges from the physics of the brain, real to us even if underpinned by determinism. This compatibilist view reframes freedom not as breaking the chain of cause and effect, but as being part of it in a way that allows agency. Visualize it, a river flowing from the mountains. You cannot stop its current. It will reach the ocean no matter what. Yet within the river, eddies form, swirls dance, paths diverge. You are one of those swirls, shaped by the flow, inseparable from it, but still unique. In this metaphor, free will is not absolute freedom, but patterned motion within inevitability. The arrow of time still marches forward, but within its march, there is room for choice-like behavior. Philosophically, the illusion of free will ties back to meaning itself. If life is predetermined, does that render it less significant, or does it grant it a kind of inevitability, a script we are privileged to perform? A symphony is written before it is played, yet the performance can still be beautiful, emotional, and unique. Perhaps our lives are similar. We are not the composers, but the musicians bringing time's melody to life. And yet, the haunting question lingers. If free will is an illusion, why does it feel so real? Why would evolution craft a brain that believes in freedom if none exists? One answer is survival. A species that feels empowered to choose is more likely to act, to adapt, to persevere. The illusion may not reflect reality, but it drives behavior that ensures survival. In this sense, free will could be nature's most exquisite trick, a psychological tool to propel life forward. But this trick carries with it both wonder and despair. Wonder, because it suggests that meaning is not found in ultimate freedom, but in lived experience, in the feeling of choosing even if the choice was inevitable. Despair, because it strips us of absolute control, making us actors in a play we did not write. To live with this paradox is to live at the edge of science and philosophy, where certainty dissolves and mystery reigns. As the section draws to a close, the contrast remains unresolved. Time may be fixed like a block, or branching like a tree, or uncertain like a quantum wave. But in every model, our sense of choice is called into question. The arrow of time carries us forward, yet whether we steer it or merely ride, its current is unclear. Perhaps free will is neither wholly true nor wholly false, but a story we tell ourselves in order to keep moving through the labyrinth of time. And perhaps, in the end, the story itself is enough. Close your eyes, and the universe vanishes. Open them, and suddenly there's light, motion, the hum of passing time. Without consciousness, what does time mean? Does it exist independent of us? Or is it a construction of the mind? An intricate illusion crafted by neurons to impose order on chaos? For centuries, time has been treated as a physical dimension, a coordinate woven into the fabric of the cosmos. Yet, growing fields of neuroscience and philosophy suggest that time, at least as we experience it, may be the handiwork of consciousness itself. Consider memory. The past exists in no tangible form. It is not etched in the stars or written in the air. And yet, we can summon images, sounds, entire experiences of what has already vanished. Memory is not a passive recording. It is active reconstruction, stitched together by the brain. Every time we remember, we are not replaying the past, but rebuilding it, weaving fragments into a story. Without memory, the past dissolves, leaving only a timeless present. Thus, consciousness does not merely recall time, it creates it. Then there is anticipation. Humans live not only in what is, but in what might be. The brain constantly projects forward, simulating outcomes, rehearsing futures that do not yet exist. This predictive machinery allows us to prepare, adapt, survive. Yet in doing so, it floods our awareness with visions of tomorrow. The future, like the past, is conjured within the mind. Together, memory and anticipation carve the flow of time. One pulls us backward, the other pushes us forward, and in between, consciousness stitches a fragile present. But here lies the paradox. Neuroscientists have found that the present itself is not truly immediate. Sensory data takes time to reach awareness. Light strikes the eyes, sound waves vibrate the ears, signals travel through nerves, and the brain interprets them, all within fractions of a second. By the time we become conscious of a moment, it has already passed. Our experience of now is delayed, a living echo. To compensate, the brain constructs a seamless flow, filling in gaps, smoothing over delays, creating the illusion of continuity. Time, as we feel it, is less an external reality than an internal symphony composed by the mind. This realization shifts the focus from physics to phenomenology. If consciousness weaves time, then different forms of consciousness must weave it differently. For a mayfly, whose lifespan is measured in hours, does time race like a burning fuse? For a child, summer feels infinite, while for the aging, years vanish in a blink. The subjective elasticity of time reveals its psychological roots. Even within one mind, time stretches and compresses depending on mood, attention, and memory. A moment of terror can feel endless. A moment of joy can vanish instantly. Physics offers one arrow of time, but consciousness offers 1,000. Philosophy has long wrestled with this subjectivity. St. Augustine confessed, "What is time? If no one asks me, I know. If I wish to explain it, I do not." His insight points to the inescapable role of consciousness. Time is not simply measured but lived. The ticking of a clock marks uniform intervals, yet those intervals mean nothing without someone to feel their passing. In this sense, clocks measure change in the physical world, but only consciousness transforms change into time. Modern cognitive science reinforces this view. Studies of altered states, whether through meditation, drugs, or neurological disorders, show that time can warp dramatically. Minutes can feel like hours, hours like seconds. Patients with damage to certain brain regions lose the ability to perceive temporal flow, living in fragmented bursts of awareness. These disruptions demonstrate that time, as we experience it, is inseparable from the machinery of the brain. If consciousness falters, so does time. Now consider the possibility that consciousness is not merely a passenger, but an architect. Perhaps the mind does not just perceive time, but co-creates it with the universe. Some interpretations of quantum mechanics even suggest that observation shapes outcomes, collapsing probabilities into realities. If consciousness plays such a role, then time itself may be partly sculpted by awareness. The arrow we follow may be less a universal dictate and more a dialogue between cosmos and mind. This vision stirs deep emotions. It places humanity not at the mercy of time, but at its center, making us co-authors of the very flow that governs us. Yet it also unsettles, for if time is an illusion of consciousness, what happens when consciousness ends? Does time end with it? For the dead, is there no time at all? Only stillness? The thought is haunting, yet it sharpens the urgency of living, of experiencing each fragile moment while it exists. To visualize this, imagine a painter standing before a blank canvas. The brush strokes of memory paint the past, the strokes of anticipation paint the future, and the wet line of paint still glistening is the present. Without the painter, the canvas remains blank. Consciousness is that painter, and time is the painting it endlessly creates. And yet, mystery persists. Why should consciousness perceive time at all? Why not exist in a perpetual present, unburdened by memory or anticipation? Some argue that time perception is an evolutionary advantage, granting creatures the ability to learn, adapt, and survive. Others suggest it is a byproduct of cognition, an emergent illusion rather than a fundamental truth. Either way, it highlights a profound tension. Time may be less about the cosmos itself and more about the beings who witness it. As the section closes, we are left with a startling possibility. The universe may not contain time in the way we think. Instead, time may bloom within consciousness like a flower that withers when awareness fades. The arrow of time may not pierce reality itself, but may be a thread woven by the mind to hold the world together. If so, then we are not simply travelers within time. We are its architects, conjuring the very flow we cannot escape. Long before physics dissected time into equations and entropy, human civilizations told stories of its shape. Across continents and centuries, mythologies rose not with the image of time as a straight arrow, but as a wheel, endlessly turning, endlessly repeating. These cultural visions reveal not only humanity's struggle to understand existence, but also the emotional need to see patterns in the chaos. To them, time was not a relentless march toward oblivion, but a cycle of birth, death, and renewal. In these myths, time offered not finality, but return. In Hindu cosmology, time unfolds in vast cycles called yugas. Each yuga represents an age of humanity, from the golden age of truth and virtue to the dark age of decline and corruption. When the cycle ends, the cosmos is destroyed, only to be created again, reborn from the ashes of the old. This vision is grand and terrifying, stretching across billions of years, yet it carries a strange comfort. Nothing is ever lost forever, only transformed, awaiting its turn in the eternal rotation. The cycle of the yugas is not a countdown to an ending, but a spiral staircase where every descent is also a preparation for ascent. Buddhist philosophy carries a similar rhythm, describing samsara, the endless wheel of birth, death, and rebirth. Existence itself is cyclical, driven by karma, and liberation comes not from resisting time, but from stepping outside of it. To reach nirvana is to escape the wheel, to find freedom in timelessness. In this perspective, time is both prison and teacher, holding souls captive until they awaken to the truth that the cycle itself is an illusion. The emotional power of this vision is profound. Every life, every joy, every sorrow is both temporary and eternal, repeating in infinite variations until enlightenment breaks the pattern. In the West, echoes of cyclical time appear too, though less prominently. The ancient Greeks spoke of the great year, a vast cosmic cycle after which the universe renews itself. The Stoics believed in ekpyrosis, a fiery destruction of the cosmos followed by its rebirth, over and over again. Even within Norse mythology, time culminates in Ragnarok, a catastrophic ending of gods and worlds. Yet from the wreckage, new life stirs, a fresh dawn rising after the twilight of existence. These myths, dark yet hopeful, remind us that even in destruction lies the seed of return. Contrast these cycles with the linear time of Abrahamic religions, Judaism, Christianity, Islam, where history is a line from creation to judgment. In these traditions, time is purposeful, moving toward a climax, an ultimate reconciliation. This linear vision gave the West its arrow of history, shaping how entire civilizations conceived progress, destiny, and salvation. But behind it lingers the older, cyclical vision, whispering of recurrence. Humanity has always wrestled between the two. Is time a straight path toward an ending, or a wheel turning forever? Anthropologists suggest that cyclical myths arose from nature itself. The sun rises and sets, seasons return, harvests follow patterns, life and death repeat in each generation. To early humans, existence did not resemble an arrow but a circle, an eternal return written in the soil and stars. Every dawn was a rebirth, every winter a death, every spring a resurrection. Myth became a mirror of the natural world, weaving human fate into the rhythms of earth and sky. But there is more than practicality here. There is emotional refuge. A cyclical universe softens the terror of endings. If everything returns, then loss is not absolute. Loved ones may vanish, civilizations may crumble, but the cycle promises renewal. Even death becomes less of a cliff and more of a curve, bending back toward life. In this vision, time is not our destroyer, but our recycler, a wheel that both grinds and restores. Modern science, though rooted in linear models, has occasionally flirted with cyclical visions. Theories of a big bounce suggest that the universe may expand, collapse, and expand again, endless cycles of birth and death on a cosmic scale. In such a model, entropy itself may reset, the arrow of time breaking only to be reborn. These ideas remain speculative, yet they echo humanity's oldest myths, as though science itself cannot escape the allure of the cycle. The imagery of cyclical time is cinematic. Imagine a wheel turning endlessly in the night sky, its spokes glowing with stars. Imagine civilizations rising, falling, and rising again, their ruins becoming foundations for new cities. Imagine your own life as part of this turning, each breath a link in a chain that stretches across lifetimes. Such visions captivate not just because they are beautiful, but because they grant meaning to endings. If every death is also a beginning, then despair transforms into hope. And yet, cyclical time carries its own shadow. To live in a cycle can feel like entrapment. If everything repeats, then progress is an illusion, liberation impossible, destiny inescapable. Nietzsche gave voice to this terror in his doctrine of eternal recurrence. What if you had to live your life again and again, every mistake, every sorrow, every triumph repeated infinitely? Could you bear it? Could you embrace it? The thought experiment was not merely metaphysical. It was ethical, a challenge to live so fully that eternal repetition would be a gift, not a curse. This tension between hope and despair, renewal and entrapment, runs through every cyclical myth. On one side, cycles offer comfort, promising that nothing is ever truly lost. On the other, they strip away progress, trapping us in eternal return. Humanity's stories of time are never neutral. They are emotional maps, reflecting both our longing for meaning and our fear of futility. As this section closes, the question remains unresolved. Are we moving toward an ending, as the arrow suggests? Or are we caught in a wheel, as myth insists? Is time a river flowing to the sea, or a tide that always returns to shore? In the silence between cycles and arrows, we are left with the haunting possibility that both may be true. Perhaps time is neither straight nor circular, but something stranger still, a pattern beyond our comprehension, glimpsed only in stories that echo across cultures. When Albert Einstein unveiled his theory of relativity, time itself shifted beneath humanity's feet. For millennia, people had assumed that time was a universal constant. ticking away identically for everyone, everywhere. Clocks, calendars, the rising of the sun, all seem to affirm this shared rhythm. But relativity shattered that illusion. Time, Einstein revealed, was not absolute. It bent, stretched, and curved depending on speed and gravity. Two people could live in the same universe, yet their clocks would disagree. Suddenly, time was no longer the impartial backdrop of reality. It became a participant, woven into the fabric of space itself. At the heart of this revelation lies time dilation. Imagine two twins. One remains on Earth while the other embarks on a journey near the speed of light. When the traveler returns, she has aged only a few years, while decades have passed for her sibling on Earth. The paradox feels like science fiction, but it has been tested with precision. Atomic clocks placed on fast-moving jets tick slower than those left on the ground. Astronauts orbiting Earth experience fractions of a second less than people below. The effect is small on human scales, but the principle is undeniable. Time is not universal, it is relative. This realization shakes not only physics, but philosophy. If time flows differently depending on where you stand and how you move, then what does it mean to speak of now? Our everyday sense of the present assumes a shared simultaneity, a collective now that binds us together. But relativity dissolves that unity. For one observer, two events may happen at the same time. For another, they occur in sequence. The present becomes a matter of perspective, as elusive as the horizon. In Einstein's universe, the very notion of now is fragile, an illusion stitched together by human perception. The emotional weight of this is immense. Relativity reveals a cosmos where certainty evaporates. We crave anchors, beginnings, middles, and endings. But the relativity of time suggests that those anchors are not fixed. To one observer, a star may still be shining. To another, it may already have burned out. The universe becomes a hall of shifting mirrors, where reality depends on the vantage point of the viewer. In such a cosmos, the idea of an objective timeline collapses. There is no singular story of a universe, only countless perspectives, overlapping and diverging in strange harmony. And yet, within this uncertainty lies beauty. Relativity expands our imagination, pulling us beyond the narrow confines of human experience. It forces us to confront time not as a ticking clock, but as a living landscape. Picture space-time as a vast fabric, warped by massive bodies like stars and black holes. Clocks tick slower near these gravitational giants, as though time itself were weighed down by their presence. Fall too close to a black hole, and time stretches toward infinity. An observer watching from afar would never see you cross the event horizon, only freeze in place, suspended forever at the edge. In this way, relativity transforms time into a terrain with valleys and peaks, bends and horizons. This cosmic terrain is not just theoretical, it touches human lives in subtle ways. The GPS satellites that guide cars and planes must account for both their speed and their distance from Earth gravity. Without correcting for relativity, navigation systems would drift kilometers off course within a single day. The technology that connects the modern world depends on Einstein's insights, grounding cosmic strangeness in everyday experience. Even when invisible, relativity shapes how we move, navigate, and understand the planet. Philosophically, relativity unsettles the linear narrative of time. If simultaneity is relative, then the universe cannot be sliced into a single unfolding moment. Instead, the cosmos resembles a vast block where past, present, and future coexist. Some physicists interpret relativity as evidence for the block universe, where time is another dimension, laid out all at once, like a map. In this vision, every moment that has ever existed and will ever exist is already there, eternal and unchanging. Our perception of flowing time, then, is not a reflection of reality, but a feature of consciousness. The river of time may not flow at all, It may simply be that we drift along its frozen banks. This view is both wondrous and terrifying. If all moments exist equally, then perhaps nothing is ever truly lost. Every laugh, every embrace, every fleeting joy still resides somewhere in the fabric of space-time, waiting in its eternal place. But it also raises unsettling questions about free will. If the future is already there, are we truly choosing our path, or merely moving through a script already written? Relativity opens doors not only to scientific exploration, but to existential doubt, forcing us to confront the tension between determinism and freedom. Cinematically, the relativity of time invites staggering imagery. Spacecraft streaking near the speed of light, their passengers frozen in youthful vitality while Earth spins through generations. Black holes bending starlight into spirals, their gravity trapping time itself. Entire galaxies shimmering in a space-time web that stretches and curves like liquid glass. These images capture not only the science but the philosophy, reminding us that relativity is not just a theory. It is a vision of reality that defies common sense, yet feels strangely poetic. In the end, relativity teaches us humility. Time is not what it appears to be. It bends, warps, stretches, and shrinks, defying the straight lines we try to impose upon it. The human experience of time is a narrow slice of a grander reality, a fragile perspective bound by biology and scale. Relativity does not strip time of meaning. It deepens it, revealing a universe stranger, richer, and more mysterious than we ever imagined. In its bending and breaking, time becomes not less real, but more alive, a living dimension through which we move, uncertain yet endlessly curious. There's a haunting question that sits at the crossroads of physics and philosophy. What happens when the universe faces a choice? In classical thinking, outcomes were fixed. A coin toss was uncertain only because we lacked the knowledge of every force acting upon it. But quantum mechanics destroyed that comfortable illusion. At its foundation, reality seems to branch at every moment, with particles existing in superpositions until an observation collapses them into one definite state. Yet not everyone agrees that this collapse is real. The many-worlds interpretation suggests something even more extraordinary, that no possibility is ever discarded. Every choice, every outcome, every quantum branch continues to exist in a sprawling web of parallel realities. It is a vision that is both exhilarating and unnerving. According to many worlds, when you decide to walk left instead of right, the universe doesn't erase the other option. Instead, reality splits, with one version of you walking left and another walking right. Each possibility, however unlikely, becomes a fully realized branch, carrying forward its own history. What feels to us like a singular path through life may actually be one thread in an endless tapestry of diverging worlds. The human destiny, then, is not linear but fractured, woven into countless alternate narratives. The emotional implications of this idea are staggering. Imagine the versions of yourself who made different choices, some small, some monumental. Somewhere, another you accepted a different job offer, moved to a new city, fell in love with someone else, or narrowly escaped a tragedy. The many worlds interpretation suggests that all those lives are real, each as vivid and complex as the one you are living now. In one branch, you are flourishing. In another, you may be struggling. The mirror of existence reflects not one destiny, but an infinity of selves, all walking paths you can only glimpse in imagination. But if these worlds exist, what does it mean for identity? Are you truly singular, or merely one echo among countless others? Some philosophers argue that many worlds undermines the notion of a unified self, dissolving individuality into a vast ocean of possibilities. Others see it as liberating. No choice is ever final, no path ever lost. Every fork in the road is taken somewhere. Destiny becomes less about inevitability and more about participation in a cosmic branching tree. Your story is both unique and infinite, fragile and eternal. The scientific foundation of this interpretation lies in the mathematics of quantum mechanics. When particles are measured, their wave functions seem to collapse into a single outcome. But the equations themselves never require collapse. They describe a smooth, deterministic evolution of probabilities, with each possibility continuing in parallel. Many worlds takes this literally. There is no collapse, only branching. Every roll of the dice, every quantum fluctuation, every decision splits reality into new worlds. Most of these branches are inaccessible, but according to this view, they're just as real as the one you inhabit. To illustrate this, physicists often return to Schrödinger's cat. In a sealed box, a cat's life depends on a quantum event. Until observed, the cat exists in a superposition of both alive and dead. Traditionally, the act of observation collapses the superposition into one outcome. But in the many-worlds interpretation, both outcomes persist. In one universe, the cat lives. In another, it dies. The observer, too, splits, with one version seeing life and another seeing death. Observation does not resolve uncertainty. It multiplies reality. This multiplication extends beyond the laboratory into every corner of existence. The stars, galaxies, and atoms all partake in branching. Somewhere, in one universe, humanity thrives for millions of years, exploring the stars. In another, it fades early, undone by its own mistakes. The many-world interpretation suggests that destiny is not singular, but kaleidoscopic. Hope and despair, triumph and failure, all coexist across infinite branches. The human journey is not a straight road, but a fractured web, shimmering with countless outcomes. Yet this vision carries a burden of unease. If all outcomes occur, what does choice truly mean? Do our decisions matter if every possible decision is realized somewhere? Some argue that meaning is preserved within each branch. You, here, experience one destiny, and that experience is real, no matter what occurs elsewhere. Others feel a creeping nihilism. If every possibility is guaranteed, then perhaps none is special. The tension between freedom and inevitability deepens, as the very concept of fate dissolves into endless possibility. Cinematically, the many-worlds interpretation evokes imagery of infinite corridors of glass, each reflecting a slightly different version of yourself. You walk through one and see in the corner of your eye another you, smiling at a choice you did not make. Worlds unfold like pages in a cosmic book, stacked together, yet forever separate. Time feels less like a line and more like a tree, its branches stretching outward, fracturing endlessly, each tip representing a unique reality. It is a vision both haunting and sublime, where destiny is not a single thread but a forest of paths without end. In the end, the many-worlds interpretation invites both wonder and humility. It tells us that our universe may not be alone, that our lives may be only one note in a symphony of infinite variations. It asks us to reconsider identity, destiny, and meaning, not as fixed certainties, but as ever-branching possibilities. Whether or not many worlds is true remains a matter of debate, but its imagery lingers. The fractured pathways of alternate time may not just be science fiction. They may be the hidden architecture of reality itself, a reminder that the universe is stranger, vaster, and more mysterious than we can ever fully grasp. The human mind struggles when faced with infinity. We measure our lives in years, our histories in centuries, our planets in eons. But what if the true stage of existence is far larger than anything our species has ever dared to imagine? What if the universe we see through telescopes, the galaxies, stars, and cosmic webs, is only one room in a mansion of infinite chambers? This is the unsettling and awe-inspiring proposition of the multiverse hypothesis. It suggests that our universe may not be unique at all, but merely one of countless others, each with its own laws, constants, and destinies. The multiverse emerges naturally from several frontiers of modern science. Inflation theory, which explains the rapid expansion of the cosmos in its earliest moments, implies that inflation may not have ended everywhere. In some regions, expansion might still be occurring, bubbling off new universes endlessly like foam on the surface of an infinite ocean. Each bubble universe could be sealed from the others, carrying its own physical laws. In some, gravity might be stronger. In others, chemistry may unfold differently, preventing stars or life from forming at all. Our universe, then, would be just one bubble among an uncountable froth, fragile yet luminous in its improbability. Another pathway to the multiverse arises from string theory. According to this framework, the universe's deepest building blocks are not particles, but vibrating strings of energy. For the mathematics to work, string theory requires extra dimensions beyond the three of space and one of time we inhabit. These dimensions could fold in countless ways, each configuration producing a different kind of universe. The string landscape, as it is called, may contain 10 to the power of 500 possible universes. The number is so vast it defies comprehension. More universes than grains of sand on all the beaches of Earth. If true, then our cosmos is simply one realization among a nearly infinite expanse of possible realities. Quantum mechanics offers yet another doorway. The many-worlds interpretation, which imagines reality splitting at every quantum event, is itself a kind of multiverse. In this picture, alternate versions of you exist in parallel, making different choices, living different lives. These quantum branches may be as real as the stars we see, suggesting that the multiverse is not just cosmic, but deeply personal. Infinity is not just out there. It lives in the fractures of our own existence, multiplying destinies in silence. Yet the multiverse is not merely a scientific idea. It is also a philosophical and emotional earthquake. If there are infinite universes, then what does it mean to say ours is special? The Copernican revolution dethroned Earth from the center of the cosmos. The multiverse threatens to dethrone the universe itself. The vastness it proposes is humbling to the point of vertigo. In an infinite ensemble, everything that can happen does happen. Somewhere, there may be a universe identical to ours in every detail except one. Perhaps you chose tea instead of coffee this morning. Somewhere else, the pyramids were never built. In another, life never arose at all. Infinity erases uniqueness, scattering every possibility across an endless sea of realities. But paradoxically, this vastness also highlights the miracle of our own existence. For life to emerge, our universe's laws must be delicately tuned. Change the strength of gravity, the charge of the electron, or the expansion rate of the cosmos by the tiniest fraction, and stars could not form, chemistry would fail, and life would vanish before it began. This fine-tuning has long puzzled scientists and philosophers. Why do the constants of nature fall into such a narrow, life-friendly range? The multiverse offers one explanation. In an infinite variety of universes, most are barren, but a few, like ours, possess the rare conditions that allow observers to ask the question. We're here not because the universe is designed for us, but because only in such a universe could beings like us arise. The imagery of the multiverse is staggering. Imagine standing at the edge of reality, peering into a cosmic foam where bubbles of universes shimmer and drift, colliding and splitting in a never-ending dance. Some glow with stars and galaxies, others remain dark and silent. The multiverse evokes visions of infinite corridors of possibility, stretching beyond imagination. To watch it unfold is to witness not a universe, but a vast architecture of infinities, where each reality is a single brushstroke in an eternal canvas. Yet the hypothesis is not without its critics. Some argue that the multiverse is unscientific because its other universes may be forever inaccessible to observation. Science thrives on testable predictions, and if the multiverse lies beyond detection, can it truly belong in the realm of physics? Others counter that the multiverse is not an invention but a consequence, flowing naturally from theories already supported by evidence. Inflation, quantum mechanics, and string theory did not set out to create a multiverse, but their mathematics seems to demand it. Whether or not we can see the other universes, the logic points toward their existence. Philosophically, the multiverse confronts us with a strange duality. On one hand, it diminishes us, dissolving our universe into an infinite ensemble. On the other, it ennobles us, placing humanity within a grandeur beyond comprehension. To live in a multiverse is to exist at the crossroads of necessity and chance, fragility and abundance. Every breath you take may echo across countless worlds, mirrored in some, absent in others. The meaning of existence becomes not smaller but richer, entangled in the vastness of what might be. In the end, the multiverse hypothesis may remain forever beyond proof or disproof. But even as an idea, it reshapes how we see ourselves. It whispers that reality may be far greater than the sliver of cosmos we call home. It reminds us that the architecture of existence may be infinite, layered, and unknowable. And it invites us into awe, a reminder that our universe, however vast, may be but one note in an eternal symphony, ringing across the corridors of forever. At the center of human existence lies a question that science and philosophy have wrestled with for centuries. Do we truly choose our own paths, or are our choices illusions shaped by forces beyond our control? In everyday life, free will feels undeniable. We decide what to eat, who to love, what roads to walk. Yet when examined against the backdrop of fractured time, quantum uncertainty, and the multiverse, the notion of free will begins to dissolve into paradox. If all choices exist somewhere, if every outcome unfolds in another branch of reality, then what does it mean to choose at all? The experience of free will is one of the most intimate aspects of consciousness. Every human being lives with the sensation of agency, of steering their life forward. We feel responsible for our actions, bound by moral frameworks that assume we could have chosen otherwise. Without this belief, law, ethics, and society itself would lose their foundation. Yet beneath this subjective certainty lies a troubling tension. Physics paints a picture of a universe governed by laws that operate with precision, dictating how particles move, how stars burn, and how galaxies collide. If those laws are absolute, then our thoughts and decisions may simply be the outcomes of deterministic processes. Classical determinism imagined the universe as a great clockwork. Given the position and velocity of every atom, the future could be calculated with infinite precision. In such a cosmos, free will is a mirage. Every choice was written from the beginning of time. But quantum mechanics complicated this vision. At the quantum level, outcomes are not strictly determined. They unfold as probabilities. The spin of an electron, the decay of a particle, the path of a photon, all exist in superpositions until they resolve into one outcome. Some see in this uncertainty a foothold for free will, as if randomness could liberate us from determinism. Yet randomness is not freedom either. A dice roll may be unpredictable, but no one mistakes it for a conscious choice. The paradox deepens when we consider interpretations like many worlds. If every quantum event creates a branching of realities, then every choice we make splits into countless versions. In one universe, you choose to stay. In another, you choose to leave. All possibilities are realized. From this perspective, free will seems irrelevant. You do not decide between paths. You walk them all, in different branches of the multiverse. The sensation of choosing is real, but its consequence is diluted by the infinity of outcomes. Choice becomes participation in branching rather than selection between alternatives. And yet, the human heart resists this conclusion. We do not live in infinite branches. We live in one, experiencing one timeline. Within our lived perspective, choices matter deeply. To forgive or to condemn, to create, or to destroy. These decisions shape the story of our lives. Even if infinite versions of us exist elsewhere, the one writing these words and the one reading them experience reality as singular. For us, the branch we inhabit is not interchangeable with another. In this sense, free will may be an emergent truth, real at the level of experience, even if fractured at the level of the cosmos. Philosophers describe this tension as compatibilism, the idea that free will can coexist with determinism. From this view, freedom does not require absolute independence from the laws of physics. Instead, it requires that our actions flow from our character, desires, and reasoning. Even if those desires arise from prior causes, they're still ours. A person who acts because of who they are, rather than under compulsion from outside forces, is free in a meaningful sense. In this way, free will may survive as a practical reality, even if metaphysical freedom remains elusive. Cinematically, the paradox of free will invites imagery of crossroads and mirrors. Picture a lone traveler standing at a fork in a dark forest, the path dividing into countless shimmering trails. Each trail stretches into a different version of destiny, some bright, others shrouded in shadow. The traveler lifts their lantern, uncertain yet compelled to choose. As they step forward, the trails do not vanish. They echo outward, taken by other selves and unseen worlds. But for the traveler in that moment, the step matters. The choice is real, even if it is only one among many. There is also an ethical weight to this paradox. If every possible action occurs in some branch of reality, are we absolved of responsibility? Can we say, in another world, I chose differently? Such reasoning feels hollow. Responsibility, like choice, exists within the perspective we inhabit. The lives we touch, the harm we cause, the kindness we offer, these exist in our world, not in hypothetical branches. To deny responsibility is to deny the lived reality of others who share this timeline. Thus, free will may be fractured in theory, but in practice it binds us to accountability. The paradox also reshapes how we think about destiny. If time is fractured, if every outcome unfolds somewhere, then destiny is no longer a fixed path, but a field of possibilities. Some may find this terrifying, dissolving the security of a singular fate. Others may find it liberating, a reminder that the future is vast and full of potential. To exist in fractured time is to live in tension, bound by laws yet haunted by infinity, choosing while knowing that other choices echo beyond our sight. Science fiction often explores this paradox with haunting clarity. Characters encounter versions of themselves who made different choices, confronting the consequences of paths not taken. These stories resonate because they echo our deepest anxieties and hopes. Who might we have become? Who might we still be in some other world? The multiverse becomes a mirror not just of physics, but of psychology, reflecting the weight we place on every decision. In the end, the paradox of free will in fractured time cannot be resolved neatly. Perhaps free will is real, but only in the narrow sense of lived experience. Perhaps it is an illusion, a byproduct of consciousness navigating laws too vast to comprehend. Or perhaps it is both, illusory in the absolute sense, but profoundly real in the human sense. What is certain is that the question itself reveals the mystery at the heart of existence. We are creatures who ask not only what the universe is, but what it means for us. The paradox does not diminish the human story, it enriches it. It frames our lives as fragile and luminous, suspended between determinism and freedom, certainty and mystery. Whether or not free will exist in the ultimate sense, we live as if it does, and in doing so, we create meaning. In fractured time, amid infinite branches, the choice to wonder, to question, and to seek truth may be the most profound freedom of all. From the earliest flickers of consciousness, humans have sensed that time moves in one direction. We remember the past, anticipate the future, and inhabit a fleeting present that slips through our fingers. But what gives this arrow its direction? Why does time seem to flow inexorably forward, carrying us from birth to death, from order to decay? This question is not merely philosophical. It lies at the heart of physics, cosmology, and the ultimate fate of the universe. The arrow of time binds together entropy, causality, and the cosmic story itself, defining the structure of reality as we experience it. Entropy, the measure of disorder in a system, is central to the arrow of time. In every closed system, entropy increases, a principle formalized in the second law of thermodynamics. A broken cup will not spontaneously reassemble. Heat will not flow from cold to hot without intervention. These processes create an asymmetry between past and future, giving time a direction. The universe, from the Big Bang to the present, has evolved from low-entropy beginnings toward higher-entropy states, unfolding a grand narrative of transformation. This thermodynamic arrow underpins our perception of time. It moves from what was ordered to what is increasingly chaotic. Yet the cosmos is more complex than this simple picture. On the scale of galaxies, stars, and black holes, entropy takes astonishing forms. Stars burn nuclear fuel, radiating energy, and creating heavier elements that eventually collapse into supernovae, seeding the cosmos with matter for new stars and planets. Black holes, those enigmatic wells of gravity, concentrate entropy in ways that challenge our understanding of physics. Each astronomical process, while vast and distant, reflects the same inexorable drift from order to disorder, binding cosmic evolution to the arrow of time. But the arrow of time is not purely physical. It is deeply entwined with human perception. Memory, causation, and narrative all rely on a temporal direction. We recall the past, but anticipate the future. We cause effects that follow causes. Without an arrow, life itself would lose coherence. Imagine experiencing events out of sequence, feeling the consequences before the action, recalling what has not yet occurred. Consciousness seems calibrated to the universe's temporal flow, reinforcing the perception of direction, even as physics probes its ultimate origin. Cosmologists speculate on the future of the arrow of time. Will the universe continue expanding forever? Entropy rising until stars burn out, galaxies drift apart, and black holes evaporate? This heat death scenario envisions a cosmos of uniform, inert energy, where the arrow of time continues, but life and structure fade into stillness. Alternatively, some theories suggest cyclical models, where expansion reverses, leading to contraction, collapse, and perhaps a new Big Bang. In such a scenario, the arrow may bend, reverse, or restart, and the fate of the cosmos becomes a story not of linear decline, but of endless rebirth. The arrow of time also intersects with quantum mysteries. At microscopic scales, many physical laws are time-symmetric. They operate equally well forward and backward. Yet the macroscopic world, the one we inhabit, is irreversible. How does the arrow emerge from fundamentally reversible laws? Some propose that it arises from boundary conditions at the universe's beginning, a low-entropy state that sets the direction for all that follows. Others suggest that the arrow is entwined with observation, consciousness, or even the multiverse itself. Time may flow because we perceive it to flow, or because our universe was born in a special, directional state. Emotionally, the arrow of time carries profound implications. It frames life and mortality, coloring every experience with urgency. Every moment passes irreversibly. Every choice carries weight. Every joy and sorrow exists within a forward-moving current. To recognize the arrow is to confront impermanence. Civilizations crumble, stars die, galaxies fade. Yet it also imbues existence with meaning. For the fleeting nature of life and cosmos gives value to action, attention, and care. The awareness of time's passage is not a curse alone. It is a lens through which beauty, love, and wonder gain poignancy. Cinematic imagery captures this tension vividly. Picture the slow drift of galaxies in the darkness of space, nebulae collapsing and igniting in bursts of color, stars living and dying over eons. See a single drop of water shatter on stone, fragments scattering outward, never to reunite. Imagine civilizations rising, flourishing, and fading, their histories echoing like whispers in the vast corridors of time. The arrow moves relentlessly, indifferent yet sculpting the universe into narratives of birth, transformation, and eventual decay. The arrow of time also confronts human curiosity with paradox. While we move forward, physics suggests possibilities of reverse flow, cyclical recurrence, or branching multiverses. Could time bend, split, or fold, creating realities beyond our perception? Could life continue elsewhere along divergent arrows? Or does entropy impose ultimate limits? These questions merge science with existential wonder, reminding us that the arrow of time is not merely a measurement, but a gateway into the deepest mysteries of existence. Ultimately, the arrow of time is both constraint and gift. It carries us through the unfolding story of the universe, shaping events, lives, and meaning. It humbles us, revealing our fragility in the cosmic expanse. Yet it also enriches us, offering the thrill of discovery, the urgency to act, and the beauty of fleeting moments. To understand the arrow is to glimpse the architecture of reality itself, to see how past, present, and future are entwined in a delicate, irreversible dance. Even as entropy marches onward and galaxies drift apart, the arrow of time ensures that the story of existence continues. Remarkable, fragile, and endlessly unfolding.